Hello students of class 10, this is Advanced Mathematics exercise 6.2. Type 1, find the value of. Okay, this is our exercise 6.2. Type 1, find the value of. This is 15p3. Okay, find the value of 15p3. Now this is NPR formula. NPR formula in previous videos I have already said that this is n factorial by n minus r factorial. Okay, so this one 15p3, this will be is equals to 15 factorial by 15 minus 3 factorial. So this one it will be 15 factorial by this one 12 factorial. 15 factorial I can write it as 15 into 14 into 13 into 12 factorial by 12 factorial. This one cut. This if I multiply do, I will get the answer. Okay, this is, let me see, 15 into 14. 5 4s are 20, 65 1s are 5, 1 1s are 0, 1 1 210 into 13 3 0, 3 1s are 3, 3 2s are 6, 1 1 2 0 3 7 2. So this is answer is 2730. This is our answer. Okay, next number 3 I am showing you. Rest of the problems you try to do by yourself. 8p0, 8 factorial by 8 minus 0 factorial. So this will be our 8 factorial by 8 factorial, which is our 1 here. Next you see type 2. Type 2, here you see, so that, okay, type 2 saying so that number 1 NPR, okay, NPR plus R NPR minus 1 is equals to n plus 1 PR. So this one in here you see LHS NPR plus R into NPR minus 1. This one I will have to prove. So this is n factorial by n minus R factorial plus R into n factorial by this is n minus, okay, n minus R minus 1 factorial. So from here n factorial if I take common, 1 by n minus R factorial plus R into 1 by n minus R plus 1 factorial. So this one in here you see n factorial, okay, by n minus R factorial plus R by this one you say n minus R plus 1 factorial. Yes, n minus R plus 1 factorial there. Okay. So this one in here, this is n minus R plus 1 factorial there. So this will be, I will write n minus R plus 1 into n minus R factorial. Understand? This is n minus R plus 1 factorial there. Its next term will be, this one it will come n minus R plus 1, and the next term will be n minus R plus 1 minus 1. Yes or no? Minus 1. Always in factorial, 5 factorial. This means 5 into 4 into 3 into 2 into 1. 1 it is subtracted. Yes or no? So this is n minus R plus 1 factorial. Its next term will be n minus R plus 1, and its next term will be n minus R and then factorial. Okay. Now from these two you see this is n factorial by, I can bring n minus R factorial common. So this is 1 plus R by n minus R plus 1. So this is n factorial by n minus R factorial. This is LCM n minus R plus 1, n minus R plus 1 plus R. This one gone. So this is n factorial by n minus R factorial. and this will be into n plus 1 by n minus r plus 1. Okay, this is a multiply going on. So in here what I have to prove, this one you see I have to prove n plus 1 PR, yes or no? So you see this one I can write it as this one I can write it as n plus 1 into n factorial by, and this one it will be PR, r factorial I have to prove. So this one I can write n minus r plus 1 into n minus r factorial. Okay, so this one you see top, it becomes n plus 1 factorial by, and this is n minus r plus 1, n minus r factorial. So this thing it will become n minus r plus 1, this one factorial. Okay, so in here, you see this is your, now you see this is n plus 1 factorial, yes, by this one what I will do, n minus r plus 1 there, no, I will write n plus 1 minus r factorial I will make. Finished. So this whole thing is equals to, I can write it as n plus 1 PR, okay, which is equals to RHS. Understand? I am doing this one one more time. Okay, I am doing this one one more time. You see it carefully. So this one in here you see I have to prove that NPR plus R into NPR minus 1 is equals to N plus 1 PR. Okay, so in here I will take the LHS. This is NPR plus R into NPR minus 1. Understand? So this one is equals to, this will be N factorial by N minus R factorial. R into this will be n factorial by n minus r minus 1 factorial. Finished. Now from here I will take n factorial common. So this is 1 by n minus r factorial plus r by this one n minus r plus 1 factorial become. This one if I solve to. Finished. So now in here you see n factorial. This one it will be 1 by n minus r factorial. Okay. Plus r by this one you see n minus r plus 1, no, so this is n minus r plus 1 into n minus r factorial become. Okay, so from now this one I can take, this is n factorial by n minus r factorial, I can take common. So ultimately in here I will get 1 plus r by n minus r plus 1. Finished. So this one in here n factorial n factorial by, this is your n minus r factorial. This one in here if I LCM take n minus r plus 1, n minus r plus 1 plus r. So this is r gone, n factorial by n minus r factorial. This is our n by n, n plus 1 by n minus r plus 1. Finish. This one I got. So this one is equals to, this thing I will write it in this way, n plus 1 into n factorial by this one it will become n minus r plus 1 into n minus r factorial. Okay, so this whole thing it becomes n plus 1 factorial by n minus r plus 1 factorial. Became. Now in here a little bit change I will make. Okay, in here a little bit change I will make. This is there, no, n plus 1. So this is n plus 1 factorial by n minus r plus 1 factorial there. This one I will make n plus 1 minus r factorial I will make. So this whole thing is equals to, I can write it as this whole thing, this is n plus 1 PR. Okay, n plus 1 PR, which is equals to RHS. Okay, now I am going to the next proof. Next one you see type 2 number 2. This is type 2 number 2 you see. N into n minus 1 n minus 2 pr minus 2 is equals to npr. So in here solution LHS n into n minus 1 pr minus 2. So in here you see this is n minus 1. This one I will get n minus 2 factorial by n minus 2 minus r minus 2. This is whole factorial. Okay. Now this one in here n minus 1 n minus 2 factorial. Yes, this is multiplied. So like that I can write. And in the denominator it will be n minus 2 minus r plus 2. This is whole factorial. So this whole thing it will become n factorial by this one and this one cut n minus r factorial. Finish. This is I got, and this one is equals to I can write npr. Understand? N factorial minus n minus r factorial. This is npr, which is equals to RHS. This much only. Again in here nothing there to do. Next one again in here you see question number 3. This is npn is equals to n minus r plus 1 npr minus 1. Okay, so in here solution you see npn is equals to n minus r plus 1 npr minus 1. So this one npn there. This one in here you see it will be npr. Okay, npr n minus 1 n minus r plus 1 into n npr minus 1. Yes, so in here I will start from the right hand side. N minus r plus 1 npr minus 1. So in here this will be n minus r plus 1. This one it will be n factorial by n minus r minus 1 factorial. So in here this one I can write it as n minus r plus 1 into n factorial by this one it will be n minus r plus 1 factorial. So in here I have to prove npr, and that is n factorial by n minus r factorial. I will have to prove here. So okay, this one in here you see n minus r factorial. Okay, so this one here say n minus r plus 1 into n factorial by n minus r plus 1 factorial means n minus r plus 1 into n minus r factorial. Yes, so now this one and this one cut. Ultimately I will get n factorial by n minus r factorial, which ultimately gives me npr is equals to LHS. That one only proved. Understand? In here n minus r plus 1 into npr minus 1 there. So this one, this meaning is n factorial by n minus r minus 1 factorial. Understand? So this one ultimately if I open the bracket I will get n minus r plus 1. This will be factorial, and this one it is there in the numerator. So this one I can write it as n minus r plus 1, and its next will be n minus r factorial, because 1 decreasing. In here this plus 1 there, no, this will decrease, n minus r factorial become. This one and this one cut. Ultimately I will get n factorial by n minus r factorial, which is npr is equals to LHS. Okay, this is our proved. So now in here question number 4 you see 1 into 1p1 plus 2 into 2p2 plus 3 into 3p3 plus dot 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 plus n into npn is equals to n plus 1p. This is a little bit mistake there. This will be n plus 1p n plus 1. Okay, this is r there. We will make it n minus 1. Okay, I have to show this one. Okay, so now in here you see, so that 1 into 1p1 plus 2 into 2p2 plus 3 into 3p3 plus dot 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 plus n into npn is equals to n plus 1 pn plus 1 minus 1. This is I have to prove. In r plus 1 there in the question, there is a small mistake. This will be n plus 1. Okay, so you will have to correct it up. So in here solution. So first of all I will write a formula here. Okay, I will write a formula here. We know that the formula is this one, you see, r plus 1, okay, r plus 1 into r factorial minus r factorial, okay, r plus 1 into r factorial minus r factorial, this will be is equals to r into r factorial. This formula you will have to remember. Okay, finished. R plus 1 into r factorial means this one r factorial, if I send that side, then plus r factorial become, that means this one, you see, the r factorial, if I multiply it, then what I will get, r into r factorial plus r factorial I will get. Yes or no? This one you see in here, this one you see, r plus 1 into r factorial, this one what become, r into r factorial, yes, plus r factorial become. Yes or no? This one if I multiply to, then this one become. From here, if this one if I bring it to left hand side, r plus 1 r factorial minus r factorial, this will be r into r factorial. This is the formula that I have written here. Okay, so now in here you see, r value, okay, r value when I will take 1, then this is 1 plus 1, 2 becomes 2 into r value I have taken 1, so in here 2 into 1 factorial minus 1 factorial is equals to 1 into 1 factorial. Finished. R value when I will take 1. When r value I will take 2, then this becomes 3 into 2 factorial minus 2 factorial is equals to 2 into 2 factorial. When r value I will take 3, then this becomes 4 into 3 factorial minus 3 factorial is equals to 3 into 3 factorial. When r value I will take 4, then 5, this is 4, 4 plus 1, 5, 5 into this will be 4 factorial minus 4 factorial is equals to 4 into 4 factorial. So this one like that it will go on, dot dot dot. Last I will write, this is n plus 1, okay, n plus 1 into n factorial, yes, this one n plus 1 into n factorial minus n factorial, this will be is equals to n into n factorial. Finished. So now this one I will add it here, okay, if I add it, then this one you see 2 into 1 factorial, ultimately this is 2 factorial only, 2 into 1 factorial means what, 2 factorial only. So left hand side add, and right hand side if I add them, then in here you see this one and this one it will cut, yes, plus 2 factorial minus 2 factorial cut, 3 into 2 factorial means what, 3 factorial only. So this one and this one I can cut. Similarly 4 into 3 factorial means 4 factorial. So 4 factorial minus 4 factorial, this one I can cut. So ultimately here what remained is, okay, similarly this is 5 into 4 factorial means 5 factorial, and then again 5 factorial it will cut, and like that it will go on, and this n factorial also it will cut. So what remained is this one, which is our n plus 1 into n factorial, n minus 1 factorial, that is 1, it will remain, minus 1 is equals to, and this side plus, it will be 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus like that dot 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 plus n into n factorial. Left hand side it will become this one, and this side you see n plus 1 into n factorial, n plus 1 into n factorial means what? this will be n plus 1 factorial. So this became n plus 1 factorial minus 1 is equals to 1 into 1 factorial plus 2 into 2 factorial, 3 into 3 factorial plus dot 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 plus n into n factorial. Finished? So this one you see n plus 1 factorial. Yes, n plus 1 factorial. This one it becomes n plus 1 p n plus 1 minus 1 is equals to 1 into 1 factorial, 2 into 2 factorial, 3 into 3 factorial plus dot 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 plus n into n factorial. Understand? So this is ultimately I can write n plus 1 p n plus 1 minus 1 is equals to this one. 1 into 1 factorial means 1p1, 2 into 2 factorial means 2p2, 3 into 3 factorial means 3p3 plus dot 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 plus n into n factorial means npn. This is our proved. That much only in here I have to do. Again in here nothing there. One time again I am explaining. First of all we will start with this formula. R plus 1 into r factorial minus r factorial is equals to r into r factorial. R value I will start from 1. If r value if I give 1, then I will this one in here I will get 2 into 1 factorial minus 1 factorial is equals to 1 into 1 factorial. Similarly, when r value it becomes 2, then 3 into 2 factorial minus 2 factorial is equals to 2 into 2 factorial. When r value it becomes 3, then 4 into 3 factorial minus 3 factorial is equals to 3 into 3 factorial. When r value it becomes 4, then 4 into 4 factorial minus 4 factorial is equals to 4 into 4 factorial. According to this formula I am putting. So dot dot dot, at last it will become, you see, n plus 1 into n factorial. This is n factorial, then this is 5 there, no, this is 4, this is 5. 1 more there. So therefore n plus 1 into n factorial minus n factorial is equals to n into n factorial I got. Now this everything I will add it. So in here left hand side you see 2 into 1 factorial, this is plus 2 into 1 factorial and minus 2 factorial, this one and this one it will cut. 3 into 2 factorial and 3 factorial it will cut, because 3 into 2 factorial means what? 3 factorial only. 4 into 3 factorial and 4 factorial it will cut, and 5 into 4 factorial and 5 factorial it will cut. Like that it will go on, and ultimately minus n factorial, this one also it will cut. So what remained here is n plus 1 into n factorial minus this 1 it will remain. 1 factorial means 1 only, and is equals to right hand side this one plus I will do accordingly. 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus 4 into 4 factorial plus dot 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 n into n factorial. So this one n plus 1 into n factorial means n plus 1 factorial minus 1 is equals to this one. Right hand side it will remain same. So n plus 1 factorial means I can write n plus 1 p n plus 1 minus 1 is equals to this will remain same. So this is ultimately I show that n plus 1 p n plus 1 minus 1 is equals to 1 into 1 factorial means 1p1 plus 2 into 2p2 plus 3 into 3p3 plus dot 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 plus n into npn. And this is our proved. I hope you have understood. Next I am going to question number 3. Okay, question number 3 I am going. So question number 3. How many numbers between 100 and 1000 can be formed with the digits 1, 2, 3, 4, 5 without repetition of any digits? How many numbers between 100 and 1000 can be formed with the digits 1, 2, 3, 4, 5? So in here total number of digits, how many there? 5 there, no? 1, 2, 3, 4, 5. Total number of digits 5 there. These are the available digits. And the numbers between 100 and 1000, they will be what? They will be 3-digit numbers. Yes or no? The numbers between 100 and 1000, they will be 3-digit numbers. So how many numbers between 100 and 1000 can be formed with the digits this? So in the formula NPR, yes, in here I am learning permutation. In the formula NPR, n represents the total number of, this one you say n represents the total number of, you can say the total permutation of n different things taking r of them at a time. Okay, and n represents the total number of given data. Yes, n represents the total number of given data, and r represents the number of data taken at a time, or in this case the numbers. The total digits that are given here is 5, and out of these 5-digit numbers, okay, I will have to make 3-digit numbers. Okay, these are the available digits given it to me, and with these available digits I will have to make 3-digit numbers. Okay, so how many 3-digit numbers I can make with these available digits? That is, in the NPR formula, n is the total number of digits. Yes, n is the total number of digits, which is in this case it is 5. N value is 5, and r is the number of digits taken at a time. In here, how many digits I will take at a time? In here, 3 digits I will take at a time, because I am making 3-digit numbers. Okay, so with these available digits, how many 3-digit numbers can be formed? Understand? So okay, question number 3 in here, you see, question number 3. How many numbers between 100 and 1000 can be formed with the digits 1, 2, 3, 4, 5 without repetition of any digit, okay, without repetition of any digit. That means 1, 1, 1, like that I cannot do. Understand? 1, 2, 2, like that I cannot do. Understand? Without repetition of any digit. Okay, 3, 3, 1, that type of numbers it will not come. Understand? Because 3 is repeated. Okay, so in here you see, in here, total number of digits, which is n, it is 5. Yes, total number of digits 5 there. Understand? And next, number of digits taken at a time. Yes, number of digits taken at a time. It is represented by r here, and it will be 3, because 3-digit number I am making. So out of these 5 available digits, at a time I will take only 3 digits from here. Okay, so total number of digits it is 5, and number of digits taken at a time it is 3. So therefore required permutation, I will say required permutation, therefore required permutation, it will be is equals to 5p3. Okay, required permutation, it will be is equals to 5p3. Or you can write number of digits that can be formed. Okay, your choice. Is equals to, this will be 5 factorial by 5 minus 3 factorial. So this will be 5 factorial by, this is 2 factorial. Finished? So this will be 5 into 4 into 3 into 2, I will stop it, 2 factorial by 2 factorial. This one and this one gone. 5 4s are 20, 20 into 3 it will be 60. So how many 3-digit numbers can be formed? It is 60. Understand? Without repetition of any digit. Understand? This much only, again nothing there. Okay. Next I will go to question number 4. Question number 4, you see. How many numbers of 4 digits, can be formed, with the odd digits without repeating any digit. Okay, without repeating any digit. So how many 4-digit number can be formed with the odd digits? Okay, so therefore first of all I will write the odd digits are, what are the odd digits? The odd digits are 1, 3, 5, 7, 9. These are the odd digits. So total number of available digit, how much? It is 1, 2, 3, 4, 5. Again 5 digits are there. Yes, total number of digits available 5 there. And out of this 5 digit, how many digit I will take at a time? Remember, I am making a 4-digit number. So out of these 5 available digits, I will take 4 digits at a time. Understand? I will take 4 digits at a time. I can take 1, 3, 7, 9. Okay, 1, 3, 7, 9, or I can take 1, 5, 3, 9, like that. Understand? Taken at a time. 4 digit I will take at a time. So therefore in here I total number of digits n is equals to 5, and then number of digits taken at a time, r is equals to, I am making a 4-digit number, so number of digits taken at a time, it will be 4. Okay, so therefore number of 4-digit how many numbers of 4 digits can be formed with the odd digits without repeating any digit? How many numbers of 4 digits can be formed? Yes, so therefore number of 4 digits that can be formed, actually this is number of 4-digit numbers actually. Okay, how many numbers of 4 digits can be formed with the odd digit without repeating any digits? Understand? Number of 4-digit, I can say number. Okay, number of 4-digit numbers that can be formed. Okay, number of 4-digit numbers that can be formed, it will be is equals to what? Available digit 5 there, and out of 5 I am taking 4 at a time. So therefore the permutation will be 5p4. So this will be is equals to 5 factorial by 5 minus 4 factorial. 5 minus 4 factorial means 1 factorial, ultimately 1 only become. This is 5 factorial means 5 into 4 into 3 into 2 into 1. So 5 4s are 20, 60 into 2, 120. So how many 4-digit numbers I can make? 124-digit numbers I can make out of these available digit without repeating any digit. Okay, this one you can have number of 4-digit numbers that can be formed with the odd digit without repeating any digit, or you do it in this number of 4-digit numbers that can be formed is equals to this one answer. Let me check the back answer. This one you see exercise 6.2 question number 4, this is 120 there. Understand? Finished? That much only. Okay, available digits you see. Available digits, it is given by n. Okay, available digits, how many? Total available digits, how many there? 5. And out of these 5 digits, how many digits I am taking at a time? 4 digits I am taking at a time, because I am making a 4-digit number. So therefore the number of 4-digit numbers that can be formed, it will be 5p4. Okay, NPR is the formula, so 5p4. This one you solve it, 120. Okay, now next I am going to question number 5 I am going. Okay, question number 5 I am going. So question number 5 you see, saying that how many odd numbers of 5 digits, how many odd numbers of 5 digits can be formed odd numbers of 5 digits can be formed with the digits 0, 2, 3, 4, 5 without repeating any digit. Okay, without repeating any digit. How many odd numbers of 5 digit can be formed with the digits 0, 2, 3, 4, 5 without repeating any digit? Okay, odd numbers of 5 digits that can be formed with the digits. So these are the available digits. Total number of available digits, how many there? 1, 2, 3, 4, 5. 5 available digits there. Yes. And how many digits I will take at a time? How many digits I will take at a time? I am making a 5 digit number. So therefore I will take 5 digits at a time. In here n value is also 5 and r value is also 5. But in here you see question number 5, in here you see solution. So I am making a 5 digit number. Yes, these are the available digits. So now in here I will make 5 boxes. I will make 1, 2, 3, 4, 5. Okay. So now in here you see, since this 5 digit number is an odd number, so therefore in the units place, okay, in the units place, what type of digits might come in the units place? Either 3 or 5. Yes, either 3 or 5. So therefore the units place can be arranged it in how many ways? The units place can be arranged it in 2 ways. Yes, the units place can be arranged it in 2 ways. Finished? Now you see the first place, which is in here units, tens, hundreds, thousand, 10,000. The 10,000 place can be arranged it in how many ways? Okay, so in here you see in the first place 0 will not come, because if 0 comes in the first place, then this whole 5 digit number will become a 4 digit number. Understand? Because 0 in front of a number has got no meaning. Yes, so therefore this 5 digit number will become a 4 digit number. So 0 cannot come in the first place. Okay, so now the first place can be arranged it in how many ways? The first place can be arranged it in 3 ways. Okay, the first place can be arranged it in 3 ways. Understand? Why 3 ways? Because 0 cannot come, and from these 4 digits, one of the digits, either 3 or 5, will go to the last place, because it is an odd number. 3 or 5 will go to the last place. So in here, let's say 0 cannot come in the first place, so 0, it is gone. Now available digits 4 there, and out of this 4 digit, one of the odd numbers should go in the last place. Yes, so therefore the first place can be arranged it in how many ways? Available digits, how many there? 3 there. Yes or no? Because 0 I cannot put in the first place, and out of this 4 digit, one of the digits will go to the last place. So therefore now available digit, how many it will be left? 3 it will be left. So therefore the first place can be arranged it in 3 ways. Yes, the first place can be arranged it in 3 ways. Now let's see the second place can be arranged it in how many ways? The second place also can be arranged it in 3 ways. How? Because in second place I can put 0 here. Yes, because in second place I can put 0 here. Understand? If I put 0 here, okay, and out of these 4 digits, one of the digit will go to the last place. Okay, this one you see. In here, these are the available digits. Yes, I'm this one looking at the second place now. Okay, second place. I already got the first place can be arranged it in 3 ways. How? I have already showed you. 0 cannot come, and out of these 4 digits, one of the digits will have to go to the last place. Either 3 or 5, it should go to the last place. So therefore, if 5 goes to the last place and 0 cannot come, available digits are 3. So therefore, the first place can be arranged it in 3 ways. Now I am coming to the second place. Now the second place, in second place, I can put 0. Yes, I can put 2, I can put 3, I can put 4, I can put 5. Understand? So now in here you see this one. out of this 5 digits, one of the digits will have to go to the last place. Yes, so one already gone. Understand? Now available digits, how many there? Available digits 4 there. Yes, available digits 4 there. Out of these 4 available digits, okay, out of these 4 available digits, one will go to the first place. Yes, one will go to the first place. 0 cannot go. Okay, 0 cannot go. So out of these 3 available digits, one will go to the first place. Understand? So therefore the second place can be arranged it in 3 ways. Because why? You see, let's say 5 goes to the last place. Okay, 5 goes to the last place. Finished? Now in the first place 0 cannot go. Okay, in the first place 0 cannot go. So the first place can be arranged it in 3 ways. So out of these 3 digits, let's say 2 goes to the first place. Yes, so from these 5 available digits, how many digits gone? 5 goes to the last place and 2 goes to the first place. Now available digits what there? 0 there, 3 there, 4 there. So therefore the second place also it can be arranged it in 3 ways. Finished? Okay. Now let's come to the third place. Okay. Now the third place, you see, the third place can be arranged it in how many ways? The third place can be arranged it in, you see, let's say 5 goes to the last place, and out of these 3 available digits, 2 goes to the first place. Okay, 2 goes to the first place. And now the second place can be arranged it in 3 ways, and out of these 3 digits, 1 digit goes to the second place. So now available digits 2 there. Yes, available digits will be 2. So therefore the third place can be arranged it in 2 ways. And the last, this is second last, means this fourth place can be arranged it in 1 way. And understand? Everything I got here. In here I will give the place values. This is units place. This is tens place. This is hundreds place, okay, hundreds place, thousands place. This one box a little bit space you given, right? Okay, and then the last thousands place, 10,000s place. Okay, so now I have told you that the 10,000 place can be arranged it in how many ways? 3 ways. Yes, therefore I will write the 10,000 place can be arranged, the 10,000 place can be arranged in 3 ways. Yes, the 10,000 place can be arranged it in 3 ways. And then next, the 1,000 place, the 1,000 place can be arranged, the 1,000 place can be arranged in 3 ways. 1,000 place also can be arranged in 3 ways. I have already told you. Next comes the hundreds place. The hundreds place can be arranged. The hundreds place can be arranged in how many ways? Hundreds place can be arranged it in 2 ways. Yes, hundreds place can be arranged it in 2 ways. The tens place. Next comes the tens place can be arranged in 1 way. Okay, in 1 way. And the last, the units place can be arranged, the units place can be arranged in 2 ways. The units place can be arranged in 2 ways. Finished? Everything solved? So therefore I will write, according to the fundamental principle of counting, according to the fundamental principle of counting, total number of 5-digit odd numbers, total number of 5-digit odd numbers that can be formed, this will be is equals to 3 into 3 into 3 into 2 into 1 into 2. 3 into 3 into 2 into 1 into 2, which is equals to 3 3 is 9, 9 2 is 18, 18 1 is 18, 18 2 is 36. So how many 5-digit odd numbers can be formed with these available digits? 36 5-digit odd numbers can be formed. That much only, again nothing. Okay, this will S 10, the thousands place can be arranged. The 10,000 place can be arranged it in 3 ways. Remember it. The 10,000 place or the first place, whatever you say, the 10,000 place can be arranged it in 3 ways. The 1,000 place can be arranged it in 3 ways. The hundreds place can be arranged it in 2 ways. The tens place can be arranged it in one way, and the units place can be arranged it in 2 ways. So according to the fundamental principle of counting, the total number of 5-digit numbers that can be formed, it will be 3 into 3 into 2 into 1 into 2, which is equals to 36. Understand? That much only there. Easy there, it is not that hard. You will have to understand. Okay, so next I will go to question number 6. So next you see question number 6. Without repeating any digit, how many 3-digit number can be formed with the odd digits? Question number 6 here, saying that without repetition, without repeating any digit, how many 3-digit number can be formed? How many 3-digit number can be formed with the odd digits? Okay, with the odd digits. So question asking that without repetition of any digit, how many 3-digit number can be formed with the odd digits? So first of all, I will write the odd digits are, okay, the odd digits are, finished? The odd digits are 1, 3, 5, 7, 9. These are the odd digits. Okay. Now, how many 3-digit number can be formed with the odd digit? 3-digit number. Total available digit 5 there. And how many digit I will take at a time? I will take 3 digit at a time. Out of this 5 available digit, I will take 3 digit at a time. Finished? The odd digits are this. So therefore, total number of odd digits, it will be is equals to, this one you give n, small letter n, it will be is equals to 5, and number of odd digits taken at a time, r is equals to, taken at a time how many? 3. Yes, taken at a time is 3. So therefore, number of 3-digit numbers that can be formed, this will be 5p3. Yes, this is 5 factorial by 5 minus 3 factorial, which is 5 factorial by 2 factorial. 5 factorial I can write 5 into 4 into 3 into 2 factorial by 2 factorial. So this is ultimately 5 4 is 20, 60 I will get. Understand? 60 is the answer. Okay, that much only, again nothing there. Okay, so in here it is very simple. Total number of words that can be formed beginning with A, it is 5p5, which is ultimately 5 factorial equals to 120. These are the total number of words beginning with A. And then I will find total number of words beginning with A and ending with Y. I have to find not ending with Y. So first of all I will find the total number of words which begins with A and ends with Y. This will be 4p4, which is 24. So therefore the total number of 4s beginning with A and not ending with Y, it will be 120 minus 24, which is equals to 96. Okay, I hope you have understood. Next I will go to question number 8. I will go. Okay, question number 8. So question number 8 in here saying, in how many ways 5 boys and 6 girls, in how many ways 5 boys and 6 girls can be seated in a long bench, so that each boy will sit between two girls. Okay, each boy will sit between two girls. So there are 5 boys and 6 girls. So this one sitting arrangement will be, they are sitting in a long bench. So total is 11. Yes, total 11. Total 11. Yes or no? Boys and girls total 11 there. So therefore this one you no need to write, just I am showing you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now you see, one boy is sitting between two girls. So this is girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl. Finished? Total number of boys 5 there, and total number of ways in which these 5 boys can sit, it will be total number of ways in which these 5 boys can sit, it is 5 factorial. Understand? Because total how many? Total 5 boys are there. Yes, total 5 boys are there, and their available seat is this one. This in here he can sit here, 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 or here. Yes. So 5 boys. Okay, 5 boys are there. So total number of ways they can sit, it will be 5 factorial. Okay, and 6 girls are there, and the total number of ways they can sit is 6 factorial. Okay, so how many ways 5 boys and 6 girls can be seated in a long bench, so that each boy will sit between 2 girls. Okay, so therefore I will write the 5 boys can be arranged, in 5 factorial ways. Okay, and the 6 girls can be arranged in 6 factorial ways. So therefore total number of ways in which 5 boys and 6 girls can be seated in a long bench, so that each boy will sit between 2 girls, it will be is equals to 5 factorial into 6 factorial. Okay, so 5 factorial means 5 into 4 into 3 into 2 into 1. Okay, into 6 factorial, 6 into 5 into 4 into 3 into 2 into 1. Finished? So this one in here, if I multiply it, this is 5 4 is 20, 20 into 360, 60, 120. 120 into this one, it will be 120 into 6, 606 to the 12, 6 1 the 7, 720. So 72 into 12, 2 to the 4, 7 to the 14, 2 1 the 2, 7 was the 7, 4 6 8. So 86400 ways. Understand? 86400 ways. This one you remember. Understand? The 5 boys can be arranged in 5 factorial ways. The 6 girls can be arranged in 6 factorial ways. Therefore, the total number of ways in which 5 boys and 6 girls can be seated in a long bench so that each boy will sit between 2 girls, it is equals to 5 factorial into 6 factorial, ultimately 86400 ways. Okay. Next I will go to question number 9. So next you see question number 9. How many words can be formed with the letters of the word pencil beginning with C? Okay, question number 9 saying that how many words can be formed? How many words can be formed? How many words can be formed with the letters of the word, pencil, with the letters of the word pencil beginning with C? Okay, so in here, how many words can be formed with the letters of the word pencil beginning with C? Okay, the words, it will begin with C. Finished. So C will be in the first place, that means C gone. Yes, C will be in the first place, that means C gone. And the rest of the letters that will be available will be PENIL, that is 1 2 3 4 5. 5 letters will be available, and the available places will be also 5. Understand? Available places will be also 5. Okay, so therefore I will write number of words that can be formed, with the letters of the word, pencil beginning with C, it will be is equals to, beginning with C, it will be is equals to 5p, 5 ways. Understand? That is ultimately in here 5 factorial by 5 minus 5 factorial, which is ultimately 5 factorial, which is equals to 120 I will get. Understand? So total words, how many words can be formed with the letters of the word pencil beginning with C? It is 120. Next, question number 10, you see, how many ways the letters of the word, rubber, can be arranged. So in here you see, we will follow this example. You see, it is we will follow this theorem. Okay, Theorem 3 saying that if out of n given objects P are alike of one kind, Q are alike of a second kind, R are alike of a third kind, and the remaining all others are different from one another, then permutation of all n objects taking all together will be n factorial by P factorial into Q factorial into R factorial. We will follow Theorem 3. So total number of, you see, in how many ways the letters of the word rubber can be arranged. So in here R, 2R is there and 2B is there. So according to Theorem 3, this one I will write The number of ways the letters of the word rubber can be arranged. The letters of the word rubber can be arranged. It will be is equals to, how many total letters are there? 1 2 3 4 5 6. So 6 factorial by r, 2r is there, no? 2 factorial into 2b is there, 2 factorial. That one only. Very easy. Total number of letters 1 2 3 4 5 6. 6 factorial by same letters. This is r 2 there, so 2 factorial, b 2 there, 2 factorial. So this is ultimately, you see this one, I can write it as 6 into 5 into 4 into 3 into 2 factorial. Yes, into 2 factorial by 2 factorial into 2 factorial. 1 2 factorial cut. 2 factorial means 2 only I will get. Understand? So this one, if I solve this one, it will be 2. 2 2s are 4. 2 and 4 I can cut. 2 2s are 4. So this will be ultimately 6 into 5 into 2 into 3. Yes. So 5 6 are 30. 32s are 60. 63s are is equals to 180. So number of ways is how much? 180. Okay. That one. Theorem 3 we will follow, remember. Next you see question number 11. Question number 11, it is saying, how many words not ending with W can be formed? How many words not ending with W can be formed with the letters of the word flower, Okay, how many words not ending with W can be formed with the letters of the word flower? So first of all, in here I will find the total number of words ending with W. Okay, the total number of words ending with W. Understand? So in here you see, first of all I will write, okay, so question number 11, this one, how many words not ending with W can be formed with the letters of the word flower? So first of all, in here, number of words ending with W that can be formed. Number of words ending with W that can be formed. Okay. So if the word ends with W, then available letters will be 1 2 3 4 5. 5 available letters, and there will be 5 available places. Yes, 1 2 3 4 5. 5 available places. So therefore, number of words ending with W that can be formed, it will be 5p5, which ultimately is 5 factorial, which is equals to 120. Finished? It is equals to 120. So now number of words not ending with W, that can be formed, it will be is equals to 6p6 minus 5p5. Understand? So 6p6, it is the total number of ways. Okay, 6p6, it is the total number of ways the letters in the word flower can be arranged. Understand? In here 1 2 3 4 5 6, 6 letters are there. Understand? So these 6 letters, taking all the 6 letters at a time. Okay, how many ways these 6 letters can be arranged, that it is 6p6. Understand? Total number of ways. Okay, the total number of ways the letters of the word flower can be arranged, it is 6p6. Understand? And the total number of words ending with W. Okay, total number of ending with W, it is 5p5, which ultimately gives me 120. Understand? Total number of, first of all, you see the total number of ways the letters of the word flower can be arranged. The total number of ways the letters of the word flower can be arranged, that much words I will get. Yes or no? That much number of words I will get. Understand? So first of all, the total number of ways the letters of the word flower can be arranged, it is 6p6. Understand? And then the total number of words ending with W, it is 5 factorial, which is 120. Now total, this is number of words not ending with W. It will be is equals to total number of ways the letters of the word W can be arranged minus number of words ending with W. So 6p6, if I solve it, I will get 720 minus 5p5, it is 120, which is ultimately I will get 600. This is my answer. Understand? Okay, this is the word flower there in here. 1, 2, 3, 4, 5, 6. 6 letters are there. Now the 6 letters, taking all of them at a time, how many ways I can arrange these letters? Understand? How many ways I can arrange these letters? The total number of ways I can arrange this letter is the total number of words I will get. Yes or no? Total number of words I will get. Out of those total number of words, the number of words ending with W is 5 factorial, which is 120. So therefore, number of words not ending with W, it will be 6. This is 6p6, that means 6 factorial. 6 factorial minus 5p5, that means 5 factorial. Understand? 6 factorial minus 5 factorial, which is ultimately gives me this one. Understand? Now you see question number 12. How many ways 5 towels can be put in 4 boxes? Okay, 5 towels can be put it in 4 boxes. Okay. So in here you see there are 5 towels and there are 4 boxes. 5 towels and 4 boxes. Now you see one towel, in how many ways I can arrange one towel in these 4 boxes? Okay. One towel I can put it in the first box or the second box or the third box or the fourth box. So one towel can be arranged it in 4 ways. Again, let's take the second towel, and again the second towel can be arranged it in same only 4 ways. It can be placed in the first towel, it can be placed in the first box, second box, third box or fourth box. Again the third towel, again it is same. Again it can be put it in 4 ways. Okay, the third towel also it can be put in 4 ways, because the third towel I can put it in the first box or second box or third box or the fourth box. So the third towel also I can put it in 4 ways. Understand? And then again the fourth towel also I can put it in 4 ways, and the last towel, the fifth towel also I can arrange it in 4 ways. Okay. So therefore in here you see, so in here I will write the first towel. Okay, the first towel can be put into 4 boxes in 4 ways. Yes, the first towel can be put into 4 boxes in 4 ways. Again, the second towel the second towel can be put into 4 boxes in 4 ways. Yes. The third towel, again the third towel can be put into 4 boxes in 4 ways. Yes. And then the fourth towel can be put into 4 boxes in 4 ways. Yes. And the last, the fifth towel can be put into 4 boxes in 4 ways. Understand? The first towel can be put into 4 boxes in 4 ways. The second towel can be put into 4 boxes in 4 ways. The third towel can be put into 4 boxes in 4 ways. The fourth towel can be put into 4 boxes in 4 ways. Yes. And the fifth towel can be put into 4 boxes in 4 ways. Understand? So therefore the total number of ways 5 towels can be put into 4 boxes. This will be 4 into 4 into 4 into 4 into 4. 4 into 4 into 4 into 4 into 4. So this one, if I calculate, do 4 4s are 16. 4 4s are 16. 16 4s are 64. And this is 4 4s are 16. So 64 into 16. 6 4s are 24. 6 6 are 36. 38. 4 1s are 4. 1 6 are 6. 4. This will be 12. This is 9. 10. 1 0 2 4 ways. Understand? So the total number of ways 5 towels can be put into 4 boxes. This is equals to 4 into 4 into 4 into 4 into 4 equals to 1024 ways. This much only. Again nothing there. Next you see question number 13. How many words can be formed with the letters of the words committee? So question number 13, it is, you see, it is similar to question number 10. Okay. So in here, how many words can be formed with the letters of the words committee? Let me write the question here. How many words can be formed? How many words can be formed with the letters of the word committee? Okay. So as in question number 10 we have done, same only we will do here. Okay. So we will write number of words that can be formed, with the letters of the word committee, this will be is equals to total letter 1 2 3 4 5 6 7 8 9. So 9 factorial by mm 2 times there, so 2 factorial into tt 2 times there, 2 factorial into ee 2 times there, 2 factorial. So this is in here 2 to the 4, 4 to the 8 I will get. Okay, so 9 factorial is 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay, by this will be 2 into 2 into 2. So ultimately you see 2 to the 4, 4 to the 8, 8 and 8 I can cancel. Ultimately I will get 9 into 7 into 6 into 5 into 4 into 3 into 2 into 1 I will get. Now this one if I solve it, Okay, let me do the multiplication and then I will write the answer. Okay, so if I multiply to this one answer, I will get 45,360. Okay, this is our answer, 45,360. So next you see, this is question number 14. How many ways 10 heads of different colors, okay, there are 10 heads of different colors, can be put on the heads of 10 boys sitting in a row? 10 heads are there of different colors. Okay, in how many ways these 10 heads can be put on the head of 10 boys sitting in a row, so that the red and the black colored heads can never be put on the heads of any two adjacent boys? Red and black cannot be adjacent. Okay, cannot be adjacent to each other. That is saying. Understand? 10 heads are there of different colors. They are put on the heads of 10 boys who are sitting in a row. Understand? Who are sitting in a row. Okay. Now, there is a condition. Okay, there is a condition that the red and black colored hats can never be put on the heads of any two adjacent boys. Okay, 10 hats are there of different colors. They are put on the heads of 10 boys sitting in a row. Okay, now there is a condition that the red and the black colored hats can never be put on the heads of any two adjacent boys. Understand? So in here I will write, you see, 10 hats can be arranged. 10 hats can be arranged in how many ways? 10 hats can be arranged in 10 factorial ways. Okay, 10 hats can be arranged in 10 factorial ways. Okay, now you see, number of hats excluding the red and black hat. Okay, number of hats excluding the red and black hats is 8. Total 10 hats are there. If the red and the black hat, if I exclude 2, then the total number of hats 8. Okay, total number of hats 8. Now the red and the black hat, excluding the red and black hat, right? Or hat. The red and the black hat is considered, these two hats I will consider as one piece. These two hats I will consider as one piece. That means one hat. Understand? These two hats I will consider it as one piece. Okay. Now next, therefore total number of hats, it is 8 plus 1 is equals to 9. Okay, I will explain it again. I will explain it. You just see here, 8 plus 9. So next, total number of ways red and black hat, total number of ways red and black hat are adjacent to each other, it will be is equals to 9 factorial into 2. Okay, total number of ways red and black hat are adjacent to each other, it will be 9 factorial into 2. So now total ways red and black hat, now total ways red and black hat are not adjacent to each other. Okay, the red and black hat are not adjacent to each other, this will be is equals to 10 factorial minus 9 factorial into 2, which is 10 into 9 factorial. 10 factorial means 10 into 9 factorial I can write, minus 9 factorial into 2. If I take 9 factorial common, then 10 minus 2, which is ultimately I will get 8 into 9 factorial. This is the answer. Okay. So in here you see, first of all, the question is, in how many ways 10 hats of different colors can be put on the heads of 10 boys sitting in a row so that the red and black colored hats are never put on the heads of any two adjacent boys. Any two adjacent boys, in their heads I cannot put red and black. Okay. So now you see the 10 hats can be arranged it in 10 factorial ways. Yes, the 10 hats can be arranged it in 10 factorial ways. Okay, 10 hats there and 10 boys there. Okay, so how many ways I can arrange those hats? 10 factorial ways. Now, number of hats, if the red and the black hat, if I exclude it, then the number of hats excluding the red and black hat, okay, in here if I red and black plural there, no, excluding the red and black hats, I can give as no problem. Okay, red and black hats is 8. Okay, these two hat, if I exclude it, then the total number of hats now is 8 there. Now, the red and the black hat is considered as one piece. These two hats, I will take it as one hat. So now the total number of hat is 8 plus 1, 9 there. Understand? So total number of ways red and black hat are adjacent to each other, it will be 9 factorial into 2. Okay, 9 factorial into 2. Okay, and next, total ways red and black hat are not adjacent to each other. This total number of ways that I can arrange them, it is 10 factorial. So 10 factorial minus this one I will do 9 factorial into 2. Where this is 9 factorial into 2 is the total number of ways the red and black hat are adjacent to each other. Understand? Red and black hat cannot come adjacent to each other. That one only in here asking how many ways I can arrange those hats so that the red and black hat do not come adjacent to each other. So the number of ways the red and black hat comes adjacent to each other, it is 9 factorial into 2. So the total number of ways the red and black hat are not adjacent to each other, this will be the total number of arrangements that I can make, which is 10 factorial minus the number of ways in which the red and black hat comes adjacent to each other. So this is 10 factorial means I can write 10 into 9 factorial minus 9 factorial into 2. 9 factorial common take, that 10 minus 2 I will get, which is ultimately 8 into 9 factorial. This is the answer. Okay, in here this is the important. The red and the black hat is considered as one piece. So therefore the total number of hats will be 8 plus 1, 9. Understand? So the total number of ways red and black hat are adjacent to each other, it is 9 factorial into 2. Next, the total number of ways the red and black hat are not adjacent to each other, this will be the total number of ways, which is 10 factorial minus the total number of ways in which the red and black hat comes adjacent to each other. This one is equals to answer I get it. Okay. Next you see question number 15 there. Find the value of n if this is, you see, 2 into 9 pn is equals to 10 pn. Okay, 2 into 9 pn is equals to 10 pn. So 2 into 9 pn I can write it as 9 factorial by 9 minus n factorial. This one I can write it as 10 factorial by 10 minus n factorial. Finished. N value I need here. So now in here you see this is 2 into 9 factorial, okay, by 9 minus n factorial is equals to 10 factorial. I can write it as 10 into 9 factorial by 10 minus n factorial. Finished? So now in here you see this one again, 2 into 9 factorial by 9 minus n factorial is equals to 10 into 9 factorial by 10 minus 9. Its next term it will be, you see, 10 minus n, again next term it will be 10 minus n minus 1. Understand? 10 minus n factorial, okay, this is 10 minus n factorial. It becomes what? 10 minus n into 10 minus n minus 1. Yes or no? Again next it will be 10 minus n minus 2, like that it will go on and on. So 10 minus n factorial, I can write it as 10 minus n into 10 minus n minus 1 factorial. I can write 10 minus n minus 1 factorial means what? This is 9 minus n factorial. Understand? So its next term it will be 9 minus n factorial. Finished? So in here 9 cut, 9 minus n factorial, 9 minus n factorial cut. Ultimately I will get 2 by 1 is equals to 10 by 10 minus n. Cross multiplication do then. 2 into 10 minus n is equals to 10. So this is 20 minus twice n is equals to 10. So this is minus 2n is equals to 10 minus 20. So this is minus 2n is equals to minus 10. So this is n is equals to 5 I will get. Understand? N value 5 I will get. This one you just in here remember. 2 into n pn. Okay, 2 into 9 pn is equals to 10 pn. So this will be 2 into 9 factorial by 9 minus n factorial is equals to, this is 10 factorial by 10 minus n factorial. So this one I can 10 factorial means I can write it as 10 into 9 factorial by 10 minus n factorial. 10 minus n factorial means 10 minus n into 10 minus n minus 1 factorial. 10 minus n minus 9 factorial means what? 9 minus n factorial. So therefore 10 minus n factorial I can write it as 10 minus n into 9 minus n factorial. So ultimately this one and this one it will cut, 9 factorial cut, this one I will get, cross multiplication to n value I will get it. Next you see number 2 here. np5 is to np3 is equals to 2 is to 1. Okay, np5 is to np3 is equals to 2 is to 1. So in here np5 is to np3 is equals to 2 is to 1, which I can write it as np5 by np3 is equals to 2 by 1. Okay, so now in here you see np5, that means n factorial by n minus 5 factorial by n factorial by n minus 3 factorial is equals to 2 by 1. Okay, so ultimately this will be n factorial into n minus 3 factorial by n factorial into n minus 5 factorial is equals to 2 by 1. Finished? So this one and this one cut. N minus 3 factorial I can write it as n minus 3 into n minus 4 into n minus 5 factorial by n minus 5 factorial is equals to 2 by 1. Yes, n minus 3 factorial I can write it, because n minus 3 its next term will be n minus 3 minus 1, which ultimately I will get n minus 4. Again the next term will be n minus 4 minus 1, which will be n minus 5. I can stop it in here. N minus 5 factorial. This one and this one it will cut. So ultimately I will get n minus 3 into n minus 4 is equals to 2. This one if I multiply I will get n square minus 4n minus 3n plus 12 is equals to 2. So this is n square minus 7n plus 12 minus 2 is equals to 0. So this will be n square minus 7n plus 10 is equals to 0. So this is n square minus 2 5s are 10, 5 1. So minus 5n minus 2n plus 10 is equals to 0. N common, n minus 5 minus 2 common, n minus 5 is equals to 0. So n minus 2 into n minus 5 is equals to 0 I will get. Understand? 0 I will get. So this one, after that, this one you see I am doing it in the top. Okay, so this one you can say either n minus 2 equals to 0 or n minus 5 equals to 0. So this is n is equals to 2 you will get, or n is equals to 5 you will get. Understand? N is equals to 2 you will get, or n is equals to 5 you will get. Now n is equals to 2, this is not acceptable. Okay, in here you can write not acceptable. Understand? Okay, so therefore the value of n is 5. 5 is the answer. N is equals to 2, it is it will be not acceptable. Okay, n is equals to 5 is the answer. N is equals to 2, it is not acceptable. Why it is not acceptable? Because if the total number of object it is 2, and out of 2 how you can take 5 at a time? Understand? So therefore n is equals to 2, it is not acceptable. Understand? This is np5 there. Now n, if total number of object it is 2 there, out of 2 total object is there, and out of these 2 how can you take 5 at a time? Okay, so therefore 2 is not acceptable, and value it is 5. Okay, next one again you see question number 3 here. 3 into np4 is equals to 5 into n minus 1 p4, n greater than 4 there. Okay, n greater than 4 there. So this is again solution. 3 into n factorial by n minus 4 factorial is equals to 5 into n minus 1 factorial by n minus 1 minus 4 factorial. Understand? This thing means, okay, n minus 1 p4, n minus 1 factorial by n minus 1 minus 4 factorial. Finished? So now in here 3 into n factorial by n minus 4 factorial is equals to 5 into n minus 1 factorial by n minus 5 factorial I am getting. So this one in here you see 3 into n factorial means I can write it as n into n minus 1 factorial, and n minus 4 factorial I can write it as n minus 4 into n minus 5 factorial is equals to 5 into this is n minus 1 factorial by n minus 5 factorial. N minus 5 factorial, n minus 5 factorial cut, n minus 1 factorial, n minus 1 factorial cut. Ultimately this is thrice n by n minus 4 is equals to 5 by 1 I am getting. So if I do cross multiplication, thrice n is equals to 5 into n minus 4. So this is thrice n is equals to 5n minus 20. So this is thrice n minus 5n is equals to minus 20. So this is minus 2n is equals to minus 20. Okay. So in here n is equals to 10 you will get. Understand? N is equals to 10 you will get. Okay. Next we will do the last sum, which is, this is number 4. np5 is equals to 42 into np3 n greater than 4. Okay. So this is our solution. So np5 is equals to 42 into np3 given. So this one I can write it as n factorial by n minus 5 factorial is equals to 42 into n factorial by n minus 3 factorial. Now you see in here n factorial cut. This is 1 by n minus 5 factorial is equals to 42 by n minus 3 factorial. I can write n minus 3 into n minus 4 into n minus 5 factorial. So this one and this one I will cut. This one 1 by 1 is equals to 42 by n minus 3 into n minus 4 I will get. Now if I do cross multiplication, n minus 3 into n minus 4 is equals to 42. So this one, it will become n square minus 4n minus 3n plus 12 is equals to 42. N square minus 7n plus 12 minus 42 is equals to 0. N square minus 7n, 42 minus 12, this is 0, 3, minus 30 is equals to 0. Okay, so 30, this is 3, 10, 2, 5, 5, 1. This one, our 5 to the 10. So this is n square minus 10n plus 3n minus 30 is equals to 0. N common, n minus 10 plus 3 common, n minus 10 is equals to 0. So this is n plus 3 into n minus 10 is equals to 0. So in here, either n plus 3 is equals to 0 or n minus 10 is equals to 0. So n is equals to minus 3, n is equals to 10. Okay, so since n value it is greater than 4, okay, since n value it is greater than 4, so n value minus 3 it cannot come. Okay, this is not acceptable. Understand? So therefore the value of n is, therefore the value of n is 10. Understand? Or you can keep it in this way. This one only our, again nothing there. Understand? So with this, our permutation and combination exercise 6.2 it is over. Okay, I hope you have understood. If you have any doubt, you please write it in the comment section. Okay, thank you.